Hi, I'm Brian from Simply Brian Enterprises, and welcome to my channel. Today we're going to be looking at TopTechBoy's Raspberry Pi class, lesson number 16. Now, this video is coming out pretty late. I ran into some problems, and I'm going to go through what they were, but I actually tried to record this lesson a while ago, and my code mysteriously stopped working. So I had to troubleshoot that, and I'll talk about that as we go through this lesson. As we usually do, we're going to take a quick look at the hardware, run the program, and then look at the code. So first I want to take a look at the breadboard and the way I have it set up. So I have my ADC0834 AD converter, and then I have three potentiometers. I've got red shirt Paul, green shirt Paul, and blue shirt Paul potentiometer. And then I have my RGB LED. Now, I want to make a quick point here as to this RGB LED. If you remember, a few lessons ago, I talked about the different types of RGB LEDs, and I was using a common anode, which means that we're always sending 3.3 volts into the LEDs, and we're going to control the brightness by controlling the grounds. This week, I'm using the RGB LED that comes in the Sunfounder kit, which is a common cathode, which means that all of the pins of the RGB LED are connected to ground, and then I'm going to control the brightness by adjusting the voltage. Up means bright, down means dim, the way that you would logically think of it. So one of the benefits of that is then I don't have to write code to invert it anymore. If I send the voltage high, it's going to light. If I send the voltage low, it's going to dim. And so before we go too far here, I wanted to talk about my error and what happened. I had my code working, I had set up, and I was starting to record, ran the program, and suddenly every time I adjusted a potentiometer, nothing would happen. And I wasn't sure why. And what I discovered, because I did not make any code changes, what I believe has happened is that these potentiometers that come with the Sunfounder kit, I must have bumped it enough that they actually unseated, so that when I was turning the potentiometer, where's my finger? There we go. Turning the potentiometer, basically nothing was happening because the center wiper pin wasn't making any contact. So that is a piece of information as we're using the Sunfounder kit. Be really careful with these potentiometers. The pins like to slip out of the breadboard. A note for Sunfounder would be to perhaps look at something that uses a little bit longer pins, so that when we seat these into the breadboard, they stay a little better. So when it comes to how I have these wired, I have a red shirt Paul potentiometer going into channel 0, green shirt Paul into channel 1, and blue shirt Paul going into channel 2. And I've put up a handy little diagram of the ADC chip, and you can see there's 4 analog inputs, and we're using 3 of them. So let's go to our code, and let's run the code, and let's see this work. And we'll give it a second because I'm still using VPython. VPython has been really helpful just to have a visual output. In case there's a wiring problem with my RGB LED or something, at least I know that my inputs are working, which is kind of how I diagnosed that the potentiometers weren't sending the correct value. So I'm going to go ahead and give us a little bit of red shirt Paul. And we can see that we have red in the VPython as well as on the LED. And we're going to come over here and do a little bit of green shirt Paul. And you see we've got green on the LED and a little bit of blue shirt Paul. And we have blue. Let's do a little bit of green shirt here to make a cyan. And we'll back off the blue, add in a little bit of red, maybe make a little bit of a yellowish color. I should note that the resistors I'm using on this are the, I believe they're the 2.2K. That's just so that the LED is nice and dim for the camera. The color balance does not look right in person, but on the camera it's actually a little closer to what VPython is showing. And so I'm just going to turn these down. Don't have to turn them down, but I think it's better off as we go program to program, and then we'll do a little bit of cat talk to exit the program. So let's take a look. I'm going to close out VPython here, and let's take a look at our code. So this top section, kind of what we've gone through before, VPython, RPy, GPIO. Here's the library. I went into detail on where I put that library and how I loaded it. We're going to BCM numbering versus board numbering. And the first thing I want to mention here is a couple of lessons ago, I experimented using Python dictionaries. And the reason I did that is so that instead of addressing the colors numerically by index 0, 1, 2, I could address the colors blue, green, or red, green, blue. And while that worked in some cases, dictionaries have some inherent flaws, one of which is they lack an index, so I can't just pass a Python dictionary in the same way that I'd pass an array. And so I was actually having to write more code because I couldn't pass a dictionary as an array. I couldn't build a simple loop through a dictionary because there's no index value. So in one of my videos, Keith had actually mentioned the idea of setting a variable to my index values. So I have color red is 0, color green is 1, and color blue is 2. So now as I work through these arrays, I can set it up as an array, red, green, blue in order. So I get the index of 0, 1, and 2, which if you remember is also the order on the ADC controllers, 0, 1, and 2. So that way all of my arrays kind of line up, everything is 0, 1, 2. But then for readability in code, I can address them either as the index value of 0, 1, or 2, or I can use the color value of color red, color green, color blue. So thanks, Keith, for that tip. I hadn't thought about using a variable to address an array value, and it worked splendidly, as you'll see. Setting up the frequency and clearing the cat talk counter. So here's the first iteration of using an array. I'm setting up all three of my PWMs because I have to define a PWM for each color channel. And you can see I'm setting it up as an array, and I'm addressing it by color value. So I have, here's my color red, my color green, and my color blue PWM. And then I'm going through and individually starting each one, obviously with a starting value of 0. Now that's important to note because remember I went to a common cathode RGB LED, so now I'm going to start at 0 rather than starting at 100 as I was previously. Don't forget the dot setup line to start the ADC library like I previously did in a segment of code, and thankfully caught my error before I tried to publish it. And then setting up my VPython, and now we head into our while loop. And again, I'm able to use an array, so I'm taking all of my potentiometers as one single array. I'm reading in red, green, and blue again, and then writing out the value immediately to VPython, and you can see that I'm translating. Actually, no, I'm not translating. Oh, yes, I am translating because VPython uses a scale of 0 to 1. So I have to take my color value of 0 to 255, divide it by 255, and that gives me the fraction between 0 and 1 to make sure that the output value is correct in VPython. And you can see that I'm, even though it should automatically do it, I'm forcing that to a float value just to make sure it doesn't try to do any rounding, because I wouldn't want this to try to round up to 1 or something like that when it's actually 0.73. So this is one of the areas that I was really excited to go back to using an array. Now I can do a range. I can do a loop through the array using a range. If I use a dictionary, I have to specify color, color, color. So I basically have 3 sections of code, one for each color. Now I can go back to just doing a simple loop, range 0, 3. So I take my first potentiometer and I need to convert it from the 0 to 255 scale to the 0 to 100 scale for PWM. And then I'm converting the PWM value from linear to exponential. And I've gone through this code enough times, I don't need to explain that again. And then, of course, every single time through the loop, we're writing out that value. So if I set my potentiometer, even if I don't change it, if I just leave it where it is, it's going to write that value every single time through the loop out to the RGB output pin. And again, we loop through 3 times. So we do red, green, blue, and then we go back up to the top, red, green, blue. So that way, anytime I make a change, it's going to register it immediately. Then we get to the cat talk section where we're reading the input of this pin. I want to make a point here because in the July 15th live stream that Paul did, he was demonstrating a project, a future project, and he was talking about the input latency of his push button. I think he said he had it set to something like a quarter second, and it was causing some problems in code. So I just wanted to point out the values that I'm using here. So I'm using basically false. So these are pull up. So if I press it down, it's false. If I leave it up, it's true. So I press it down, it's false. I do a back off of 0.05 seconds. And then this little 0.01 second, I'm trying to remember why I needed to do this, but the code doesn't quite work the way I want it to without this very insignificant little buffer here. So I'm not sure, I don't remember exactly why, but if you look at this, you'll see that versus a quarter second, I'm using 50 milliseconds and then the 10 millisecond delay here. And then we come out of it, and you'll notice that after we hit the cat talk, we clean up the pins, but before we do that, I'm going to actually clear out, I'm going to set all of my PWMs to 0 and then stop them. The reason for that is once in a while, I've noticed that if you don't stop the PWMs, the next time you start the program, for some reason, it will remember those values and start it at the same value where you left it. So I always want to set these to 0 and then stop them. And I do apologize for my scratchy throat. I'm not having the best day, but I wanted to get this recorded because I know it's been a little long in waiting. So I hope you enjoyed this video. If you did, be sure to click subscribe and like below. I'd love to hear your comments, some of the thoughts that, some of the things I did to overcome some challenges. Leave a comment below, let me know what you're thinking, and I look forward to hearing from you. From Simply Brian Enterprises, this is Brian. Have a nice day. Thanks for watching.